Okay, so I have a similar demo set up, except this time we're going to bring in the moon on a stick. Okay. So I've got the Earth over here, not quite as close to the sun as it was, so you can see it a little better. And again, the North Pole's here, it's leaning that way, so it'd be wintertime. This particular position would be the winter solstice. I have Dodge City right here facing the sun, so the time of day would be noon. All right, we go around Mr. Sun. The moon goes around the Earth, okay? Planets orbit stars, satellites or moons orbit planets. That's how it works. Now, if I held the moon here and you pretended you were at Dodge City, Kansas, so you're going to stand here, how much of the moon would be lit up? Well, the sun's shining on the back half. See, the moon does not produce light. The only things in the universe that produce light all by themselves are stars. Okay? Everything else converts one form of energy to another or reflects light. The moon does not produce light, the moon simply reflects it. Well, the only part of the moon that's seeing the sun's light to reflect it is the backside, and we can't see that. So when we looked up at noon, the sun's really high and bright in the sky, we would see nothing, and we call this new moon phase. All right. We go around the sun counterclockwise. We spin counterclockwise from the northern hemisphere perspective, so the moon goes around us counterclockwise. All right, so I'm going to come over here, and I'm actually going to skip this position, and I'm going to go to this position, and I'm going to spin the United States so we can look up at the moon. Now, if you're in the United States, you're here, and you're looking up, the sun's back here, the sky's dark, there's stars out here, you're seeing the entire disk of the moon lit up, and we call that full moon. Okay. So we got new moon, and we got full moon. Now I'm going to come around from this side because it's a little easier for you to see, but I need you to remember that I'm facing you, so my right is your left side, and my left is your right side. So we have a mirror image. So nothing lit up. More. The entire disk, from our perspective, the entire disk lit up, and we come over here. Now, in this position, it is 6 a.m. I've got the United States facing me. And if you were out and you looked up, you would see about half the moon lit up, or the disk you would see half of it lit up. Now here's the tricky part. You would see the left side lit up. And we call that waning quarter, or as we move here, it's going to become waning crescent, right? Because less and less is lit up, and then back to new moon. Now from here, my perspective, Dodge City, Kansas is here, it's 6 p.m., you would look up at the moon and you would see the right side lit up. That would be what we call waxing quarter or first quarter. So let's go around. We're looking up, we see nothing. This is new moon. We see a little more lit up, little more lit up, little more lit up. It's the right side, so we're waxing, okay? Waxing quarter, first quarter, more lit up. Now we got a full moon, and we go downhill from there. Less lit up. Waning quarter, less, back to new moon. Now, every now and again, not all the time, but every now and again, things line up just right. Okay, things line up just right. And the moon comes directly in between the Earth and the sun and casts a shadow on the Earth. And because the moon is blocking out the sun, we call this a solar eclipse. Every now and again, things line up just right and the Earth blocks out the moon, the light hitting the moon, and we call that a lunar eclipse. There's the thing. Solar eclipse would be here. Can we have a solar eclipse any other time than new moon? No. You can only have a solar eclipse during new moon. You can only have a lunar eclipse during full moon. You can't have a lunar eclipse here or here or here, only during full moon. Another thing, it takes the moon about a month. It's a little over 29 days. We talked about that a little bit. It's a little over 29 days to go around, to go through a complete set of phases. But we do not have a lunar and solar eclipse every month. And there's a reason for that. It's because the plane of orbit is tilted. The moon orbits the Earth on a little bit of an angle. This is a little over dramatic. It's about a 5-degree angle. Okay. So everything has to line up right to get an eclipse. Another thing, more people have seen the lunar eclipse than the solar eclipse. And that's because when there's a solar eclipse, the moon is really, really tiny. The moon's about 1/4 the size of the Earth, and the Earth is 1/100th the size of the sun, give or take. But the moon can block out the sun because it's so much closer to Earth. Even though it's smaller, it's so much closer. But what it does is it casts a tiny shadow on the Earth. So in order to see the solar eclipse, you have to be in the path of the shadow. Now, if you look at a globe, there's a lot of ocean. And a lot of times when there's a solar eclipse, it's the path of the shadows in a place that isn't very populated, so people can't see it. You can, however, book a cruise to catch a solar eclipse or an aurora borealis, but we don't always get to see it. Just because there's a solar eclipse does not mean it's visible from Dodge City, Kansas. A lunar eclipse, on the other hand, because the Earth is bigger than the moon, casts a shadow on the moon, anyone on the dark half of the Earth can see the lunar eclipse. So more people have seen a lunar eclipse than a solar eclipse. All right, one more. Let's pretend we go back to the moon. Right? And if you're on Earth and you're looking at the moon, waving at the astronauts on the moon, and you're on Earth, you are seeing a new moon. But if you were on the moon, first of all, looking at Earth, you'd be on the dark side of the moon. Right? It'd be dark. And you'd be looking at Earth, but Earth would be all lit up, so you would be seeing a full Earth. So it's a mirror image. If you're on Earth looking at a new moon, an astronaut on the moon would be looking at a new Earth. Same thing with full moon. Okay? If you were on the moon looking at Earth, you wouldn't see anything because you're looking at the dark side of the Earth and you'd be on the light side of the moon. If you're on the Earth looking at the moon, you would see a full moon. So people of Earth, full moon. People living on the moon, new Earth. Same way with your quarters. This would be new moon, full Earth. First quarter be last quarter to them, etc., etc.